Next problem is prove that the number of ways in which n different things can be distributed into r different groups is r power n minus rc1 into r minus 1 whole power n plus rc2 into r minus 2 whole power n minus dot 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 plus minus 1 power r minus 1 into rc r minus 1 if blank group are not admissible. Now, for solving this one, first we will find out n of u, where n of u is total number of way in which n different thing can be distributed into r different group if blank group is admissible. Here we have n different things, so we'll assume n different things a1, a2, a3, a4, a5, dot 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 an. Similarly, we have r different groups, so we'll assume as g1, g2, g3, g4, g5, dot 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 like gr. So here n things we have to distribute among r groups. So first thing a1 can go in any group. So a1 will have r choice. Similarly a2 will have also r choice. Similarly a3 will have also r choice. Then an will have r choice. So this r into r n times. So this will become r power n. So we can say n of u equals to r power n. So here n things we are distributed among r groups, where blank groups are allowed is nothing but r power n. Now we'll find out n of gi. N of gi, it represents number of distribution way in which ith group is blank. That means n things we have to distribute among r minus 1 group if blank group is allowed. So n of gi will come r minus 1 whole power n. Now we'll find out n of gi intersection gj. It represents number of distribution ways in which ith and jth group is blank. That means n things we have to distribute among r minus 2 group if blank group is allowed. So n of gi intersection gj is nothing but r minus 2 whole power n. Similarly, n of gi intersection gj intersection gk will be r minus 3 whole power n. Similarly, if I find out n of gi intersection gj intersection gk intersection gl is nothing but r minus 4 whole power n. Similarly, we can find out other term. Now we'll find out n of g1 union g2 union g3 union dot 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 union gr. It represents the total number of way in which at least one group is blank. This we can find out by using set theory. According to set theory, n of g1 union g2 union g3 union dot 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 union gr will nothing but sigma n of gi minus sigma n of gi intersection gj plus sigma n of gi intersection gj intersection gk minus sigma n of gi intersection gj intersection gk intersection gl plus dot 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 minus 1 power r n of gi intersection gj intersection dot 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 intersection gr. So first is sigma n of gi. So there are r groups. So number of combinations what rc 1 into n of gi minus sigma n of gi intersection gj. So among r groups, two groups we have to take intersection. So how many groups we can make? rc two groups n of gi intersection gj plus sigma n of gi intersection gj intersection gk. So among r groups, how many combination we can make for three groups? That is rc3 n of gi intersection gj intersection gk minus sigma n of gi intersection gj intersection gk intersection gl. So here we have to make four combination of r groups. That is rc4 into n of gi intersection gj intersection gk intersection gl plus dot 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 plus minus 1 power r, then only one combination will be there for all the r groups. So this will become n of g1 intersection gj intersection gk dot 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 intersection gr. Now we will put the values. So here this will become rc1 into n of gi is nothing but r minus 1 whole power n minus rc2 into n of gi intersection gj is r minus 2 whole power n plus rc3 into n of gi intersection gj intersection gk is r minus 3 whole power n minus rc4 into n of gi intersection gj intersection gk intersection gl is r minus 4 whole power n plus dot 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 plus. So this will become minus 1 power r into intersection of n of gi intersection gj intersection gk intersection dot 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 g50 is r minus r whole power n. So this formula we can write as rc1 into r minus 1 whole power n minus rc2 into r minus 2 whole power n plus rc3 into r minus 3 whole power n minus rc4 into r minus 4 whole power n plus dot 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 plus. Second last term is minus 1 power r minus 1 into rc r minus 1 into 1 power n plus 0. From here we can say n of g1 union g2 union g3 union dot dot union gr is nothing but what rc1 into r minus 1 whole power n minus rc2 into r minus 2 whole power n plus rc3 into r minus 3 whole power n minus dot 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 plus minus 1 power r minus 1 rc r minus 1. This formula tells distribution of n things among R groups where at least one group is blank. This formula is also used to find into function. Now there are two sets. A set is having n elements and a set B which have r elements. Then set A to set B mapping in such a way that at least one element of B is not mapped with any element of A. So in this case we can say this function is into function from A to B. The number of function we can find out by this formula. Now total number of A in which no blank group is allowed is n of u minus total number of way where at least one group is blank. So n of u minus n of g1 union g2 union g3 union dot 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 union gr. Here n of e is r power n minus n of g1 union g2 union g3 union gr is rc1 into r minus 1 whole power n minus rc2 into r minus 2 whole power n plus rc3 into r minus 3 whole power n minus dot 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 plus minus 1 power r minus 1 rc r minus 1 1 power n. So this formula is used to find out the total number of functions where blank group are not allowed, and this is also used to find out onto function.